In this video, we are going to talk about probability. So the probability of an event occurring is the ratio of the number of favorable or desired outcomes to the total number of possible outcomes. So in shorthand, if we were going to write this in mathematical terms, the probability, P, of an event, E, is equal to the number of favorable outcomes over the number of possible outcomes. All right, a few important things to note is that probability is always a percentage between 0 and 1. So it can be written as a percentage between 0% and 100%. It can be a decimal between 0.00 and 1.00, or it can be a fraction between 0 and 1. There are a couple different ways of describing a probability. If we were to look at this kind of on a number line, and we know that we're between 0% and 100%, 50% in the middle. Well, anything less than 50%, we would consider that an unlikely event. And then anything from 50% to 100%, we would consider that a likely event. Now, it is possible for it to fall at exactly 0 or exactly 1. So if it is exactly 0, we would say that is what we would consider impossible. And if it's exactly 1, we would say that that is certain. Okay, let's do just a quick, easy example. What is the probability of rolling a 5 with a fair die? And the word die, you'll see that come up in probability a lot. It's just a singular form of dice. Okay, so the probability of rolling a 5 is equal to, okay, so we have the number of favorable outcomes out of the number of possible outcomes. Well, my favorable outcome is that I roll a 5. My number of possible outcomes are rolling a 1, 2, 3, 4, 5, or a 6. So there are 6 total possibilities for when I roll a die. But only one of those sides is a 5. So the probability of rolling a 5 with a 6-sided die is 1 out of 6. So another way that we could write this is as a percentage. So 1 out of 6, if you put that in your calculator, 1 divided by 6 is 0.16, and the 6 keeps repeating. So we could say 0.167. Another way of writing it would be that the probability of rolling a 5, if we convert that into a percentage, that would be 16.7%. So all three of these are ways that you can write the probability. All right, let's talk about that 6 a little bit more. So the 6, the total number of outcomes, that's called the sample space. So from that example, the sample space was 6, since there were 6 possible outcomes for rolling a dice one time. But sometimes it's not that easy to determine, or it isn't given to you. And in this case, we would use a method that's called the fundamental counting principle. So first, we know that the total number of outcomes in a probability experiment is called the sample space. So you would only be using the fundamental counting principle if you're trying to find the sample space. In the last example, we didn't have to use any special way of finding the sample space because we could easily determine that if you roll a dice, you have 6 possible outcomes. Well, what if we wanted to toss a coin in addition to rolling the dice? So if I were to toss a coin, I could get heads. And if I rolled a dice at the same time, I could roll a 1. Or I could toss the coin and get heads, roll the dice and get a 2. Or I could toss the coin, get a heads, roll the dice and get a 3. So you kind of see what's happening here. You can get heads and any possible outcome from the dice. Or you could toss and get a tails and roll a 1. You could toss, get a tails and roll a 2. You could toss and get a tails and roll a 3. So again, if you toss and get a tails, you could still get any number for the dice. Okay, so our total sample space is found by counting each of these outcomes. So heads and a 1 is an outcome, heads and a 2 is an outcome. So each individual pair here is an outcome. So we would count up how many possible pairs are there. Well, if we count those up, we'd have 12. Okay, well, there's a simpler way to do this. We don't always have to list out every pair or every possible outcome. The fundamental counting principle is the shortcut for what we just did. Instead of listing them all out, we could say, well, how many outcomes are there if I toss a coin? Well, if I toss a coin, I either get heads or tails. So I have 2 possible outcomes for tossing a coin. Then you could say, well, how many outcomes do I have if I roll a die? There are 6 sides to a die, so there's 6 possible outcomes. The fundamental counting principle tells you that you can take the number of outcomes from the first event, the number of outcomes for the second event, and multiply them together. So there are 2 outcomes for tossing a coin, 6 outcomes for rolling a die, multiply 2 times 6, and you get 12. Another way of doing this is using a tree diagram. So this is just another way of listing it out. So again, if you toss a coin and roll a die, well, you have 2 outcomes for rolling a coin. You can get heads, or you can get tails. Now, similarly to what we did before, you can roll head, or you can toss, get a heads, and then roll a 1, or you could roll a 2, or you could roll a 3, a 4, 5, or a 6. Same thing with tails. You could toss and get tails and roll a 1. You could toss and get tails, then roll a 2, and so on. So this is what we would call a tree diagram, and instead of listing them all out the way we did the first time, it just makes it a little bit shorter so that you can count up a little bit quicker. Either way, what we would do is count up. So And if you were to list it out this way, you would say heads and a 1 is one outcome. Heads and a 2 is an outcome. Heads and a 3 is an outcome. Heads and 4. And you would just keep on listing them out. So there's a total of 6 outcomes here. And then if you did the same thing with the tails, tails and a 1 is an outcome, tails and 2, tails and a 3, tails and 4, and so on. Again, if you count them up, that's a total of 6 outcomes. So you would add 6 plus 6 is 12. All right, if you toss a quarter, a dime, and a nickel, let's see what would happen here. Well, let's see. A quarter, you have 2 outcomes, heads or tails. A dime, you have 2 outcomes, heads or tails. A nickel, you have 2 outcomes, heads or tails. So, using the fundamental counting principle, 2 times 2 times 2 is 8. Okay, what about rolling 2 dice? So for the first, you have 6 outcomes. For the second, you have another 6 outcomes. So 6 times 6 is 36 possible outcomes. All right, what about selecting a month of the year and a day of the week? Well, for each month, there are 12 months in a year, so you have 12 options for a month. And then for a day of the week, there are 7 days in a week, so 12 times 7 is 84. So you have 84 possible outcomes or different combinations of a month and a day. Right, what about how many outfits from 3 sweatshirts, 4 shirts, and 6 pairs of pants? Okay, well, I have 3 sweatshirts, 4 shirts, and 6 pairs of pants. Multiply those together and you get 72 possible outfits. Okay, make a dessert from the choices below. So imagine you are at an ice cream shop and you get to choose any combination from this menu. Okay, so first, do you want a cone or do you want a bowl? You have 2 options. Then for your flavor, do you want chocolate, vanilla, strawberry, Rocky Road, or mint? That's a total of 5 options. Then do you want sprinkles, hot fudge, caramel, or nuts? That's a total of 4 options. So 2 times 5 times 4 is a total of 40 possible combinations of your ice cream. All right, so that is really all there is to the fundamental counting principle. It's just multiplying the total number of outcomes from each event if you have multiple events going on. So it's important to remember that this is only used, you're only ever going to do this when you're looking for the sample space or you're looking for the total number of outcomes.